Hi, my name is Kurt Wilkinson, and this is my discussion-based assessment. For this assignment, I'll be teaching you the most important lessons that I think are teachable. For the first part, we're learning about 6.01 Trigonometric Identities. So, without further ado, let's begin. So, let's define some vocabulary. So, an identity is something that is always true. A trigonometric identity is something that is always true in terms of a trigonometric function. And when you have trigonometric identities or functions, you're most likely going to be dealing with SOHCAHTOA, which is something that you have most likely learned before. So for review, we know that SOHCAHTOA, so is opposite over hypotenuse, adjacent over hypotenuse, or ka, and then toa would be opposite over adjacent. In terms of a right triangle, it would look like this. So this would be adjacent, opposite, and hypotenuse. Okay? And there are usually identities that go with trigonometric functions. So first one we have here, first let's put some values. So let's say we put 7 for hypotenuse, 6 for opposite, 5 for adjacent, okay? Sine of theta would be 5 over 7 because it is so. Cosine of theta, it would be 6 over 7. Cosine theta would be 5 over 7. And then tan of theta would be 6 over 5, okay? And then there's also cosecant, secant, and cotangent, so that would look like this. So CSC theta would be 7 over 6 because it's a reciprocal of sine, so you flip that, so that's what a reciprocal is. And then secant would be the same thing, you flip that, that would be 7 over 5 instead of, well, 5 over 7. And then cotangent of theta would be 3 over 4, okay? Now, it's not just SOHCAHTOA that's involved with this type of lesson, no. We're gonna have things like reciprocal identities, even and odd identities, quotient identities, odd identities, Pythagorean theorem identities, and cofunction identities. So let's start with reciprocal. So reciprocal, which basically means it's flipped, okay? And let's start off with sine. So sine of theta, that would be 1 over cosecant, or CSC, as it stands for, of theta. And then cosine of theta would be 1 over secant. And then tangent of theta would be 1 over cotangent. Secant theta would be 1 over cosine theta. And finally, cotangent theta would be 1 over tangent theta. So keep in mind, these are the formulas you would need to know if you want to find the reciprocal. Okay. Now let's move on to the quotient. Okay. Quotient identities are only 2 formulas. So let me write this out. Quotient identities. Okay. Which are tangent of theta would be sine of theta over cosine of theta. And then cotangent of theta would be cosine of theta over sine theta. Okay? And then the interesting thing about even identities and non-identities is that there are four odd identities and 2 even identities. So here's even, here's odd. Let's start with even. So cosine of negative theta, which is cosine theta, and then secant of negative theta would be secant theta. Okay? Now these even identities means that they're positive. Okay? Let's go for odd. Sine negative theta would just be negative sine of theta. Tangent negative theta would be negative tangent of theta. Secant negative theta would just be cosecant theta, but negative cosecant theta, my bad. And then cotangent negative theta would just be negative theta, negative cotangent theta. Yeah. Okay. Now, there's also the, I mentioned this before, the Pythagorean identities. So if you remember, if you recall the Pythagorean theorem, so I'm just going to write PHY, just for short, because for the sake of time. Okay, PHY. Okay, we know that a squared plus b squared equals c squared. We learned that before, right? Well, what if you add sine and cosine? So let's try that. So sine, since they're squared, it would be sine squared, and then theta, which is the Greek symbol, plus cosine squared, which will become, if the squared goes before theta, that would equal 1. Since they obviously would equal 1. Now, what if you, let's say, divide the whole thing by sine squared of theta? Well, we know sine squared of theta would cancel out. Not necessarily cancel out, I'm sorry. But it would just be 1, okay? And then if you multiply it with cosine, it would just become cotangent. I was going to run out of battery soon. And yeah, and then since sine squared theta times 1, that would just be cosecant. So here's what it would look like. It would just be 1. So the ones that have to go in front. And then cotangent squared theta equals cosecant. Yeah, I should have gotten a bigger whiteboard, but this is all I got. Okay, now let's say you have the same problem. So sine squared theta plus cosine squared theta equals 1. Divide everything by cosine squared of theta. You're left with let's see what's I'm thinking. Oh yeah, you're left with 10 squared theta, obviously, and then cosine squared theta, cosine squared theta, that would just be 1. And then 1 divided by cosine squared theta would just be secant theta. Secant squared theta. So you can rewrite this as 1 plus tangent squared theta equals secant squared theta. Okay. Now, last but not least, we got the co-function identities. So co-function. Okay. Now, if you recognize this symbol, it stands for 90. Okay. So if you have pi over 2, that means it's 90. If it's just pi, it's just 180. Okay. And when you apply this to the functions, it would look like this. It would look like 9. Or you could put pi over 2, but for the sake of simplicity, I'm going to put 90. So 90 minus theta, a sine of 90 minus theta would equal cosine theta. And then cosine 90 minus theta would just equal sine theta. Tangent of 90 minus theta would just equal cotangent theta. Cosecant of 90 minus theta would equal secant theta. And cotangent of 90 minus theta equals tangent of theta. And then finally, secant theta would be 90 minus theta would equal, I think, that would be cosecant theta. Okay. Now, equivalent in terms of this type of situation would be like if, say, like if the two angles of cosine and sine, if they add up to 90, then they are equivalent. And then it will look like something like this if we have a function. So let's start from the top. Let's start with cosine 0 theta equals sine 90 equals 1, and then cosine 10 theta, which would equal sine of 80 equals 90, and then cosine 20 would equal sine of 70. Cosine 30 equals sine 60. And cosine 45 equals sine 45, since they add up to 90. And then cosine 60 equals sine 30. So you can start to notice that they're going vice versa, if that makes sense. You know, let me just finish it up, and you can kind of see why. So cosine 90 degrees equals sine 0. So as you can see, it's kind of the opposite. It kind of switches back and forth. So yeah. So whenever the two angles add up to 90, the two functions, if they're co-functions, of course, they will have the same value. So that's what I'm trying to say right here. Okay, so that's it for 6.01. Thank you for watching.